In this video, we are going to have a look at different blockchain nodes. Let's first have a look what is actually a blockchain node. An Ethereum blockchain node implements the Ethereum protocol. It probably connects also to other nodes, but it gives you access to the blockchain. Eventually, it can do also more things, like mining, for example. But first and foremost, it implements the Ethereum protocol. There are different nodes available. The first nodes were written in 3 languages. One language was Go, which is the Go Ethereum or Geth node. It's the most popular and we will use it throughout this course. Then there was one implementation in C++ and one in Python. The reason for 3 different implementations was that you can verify that your chain is processed correctly. Now there's also a new node called Parity and it's written in Rust. And there are some other clients like MetaMask, which is a plugin for Chrome. And is not really a full node, it's more like a bridge, but more on that later. What is also available is the simulation of the Ethereum protocol. One program here is the Ethereum.js TestRPC. The reason why we want to do that is that testing smart contracts take a lot of time if we do it with a full node like the Go Ethereum node. Here with the Ethereum.js TestRPC, the mining is simulated. It takes almost no time to run through a whole array of tests. And it's very easy to set up. This is done by simulating the mining, and that's working blazing fast. Let's have a look of full nodes versus light clients. We hear a lot of new light clients now, and they are currently in development. A full node downloads the whole blockchain, and that's very large. That's over 30 gigabytes now, and it's very resource intensive. Now, if you have like a low-end hardware like phones or embedded systems, you cannot do that. It's not possible. This is where the light Ethereum sub protocol comes in. It's currently in development, but once it's in place, it will only download the headers. That's around 1 kilobyte every 2 seconds. And then it will see the data that is concerning the client and will fetch this data. It has the full functionality in terms of safely accessing the blockchain. It's just currently in development and it will come up very soon. How does Geth look in practice? First, you have to download it. It's like another piece of software that you install. You can go to geth.ethereum.org/downloads and you just download the package that you want or is suitable for your operating system and you install it. It's very simplistic. There is not much behind it. So there is no updating daemon or something else. If you want to update it, you have to check for new versions frequently. As of recording this video, the current version is 1.6.6 and there is new versions coming almost weekly. Then you open a command line or a shell, depending on your system, and you go either to the Go Ethereum install location, or if you have the Go Ethereum install location in your path, you just type in Geth. Once you start Geth, a new process will start in the background, and it will print a lot of information. It's like starting MySQL or any other client that you can start via your command line or via your shell. Geth will then open a port, UDP port 3033, and try to connect to other nodes. It's looking like this. So I've started here Geth, and then it will print out a lot of information. The most important information is at the end. This is the IPC endpoint, and it's the port where it's opening the UDP connection. Geth is downloading data into default directories unless you give it a data tier parameter. By default, Geth will work in these 3 directories. On Mac, it's in your home library Ethereum. On Linux, it's in your home/.ethereum. And on Windows, it's in your app data roaming Ethereum folder, which is usually in your users/appdata/roaming/Ethereum folder. Geth also accepts plenty of other parameters, which we will use later on. Let's have a look at the Geth standard port and the IPC file. When you open Geth, it will try to talk to other nodes and the blockchain on UDP port 3033. And what we had in the past, and what I saw a lot of times, is that people have 2 nodes running at the same time, and then it will throw an error. So if there is an error that it says it cannot communicate on port 3033 or it cannot open the port 3033, then the first thing that you have to look is that the port is not yet used. Geth will also put an IPC file into the data tier directory. This is used for other processes connecting to Geth. An IPC file is an inter-process communication file. And programs like Mist or the Ethereum wallet, or even if you just want to attach to the Geth console, it will try to connect to this IPC file. On Windows, that's working fine. But on Linux or on Mac, you have to keep this in mind, and we will talk about this later again. And there's only one thing that you have to keep in mind. Only one blockchain node can and frankly should run at the same time. Here again, the IPC file and the port. It will print it out, the IPC file here, and the port here. Nothing to worry and nothing to write down at this point. We will come back to this later. Let's have a look at the Ethereum.js TestRPC in practice. This is used in combination with automated testing, and again, it's great because it only simulates the environment. There is no mining needed, there is no huge setup needed. You just start the Ethereum TestRPC and it will give you 10 accounts with 100 Ether each, and you can start working with that. The TestRPC is downloadable via the Node Package Manager. So first thing that you have to install, if you haven't installed it yet, is Node.js and the Node Package Manager that comes with Node.js. Then you open a console or a shell and you install the Ethereum.js TestRPC. There is different versions of the Ethereum.js TestRPC, and currently there is a new beta version where you just have to install the TestRPC and no other software, which makes the thing really easy. Before you had to install a lot of other software packages, but now if you type in npm install -g for global, Ethereum.js TestRPC at beta, then it will download the beta version, which is completely pre-packed with all the software packages that you need and Ethereum TestRPC depends on. If you want to have more information on the difference between the normal version and the new beta version, or if the beta version is not working, have a look and visit the truffleframework.com/blog/removing installation issues continue TestRPC. But rest assured, we will also do this later on together. One last thing I want to talk about is MetaMask. MetaMask is a plugin for Chrome. It's like a bridge to the blockchain. It's not a full node and it's also not a light client. MetaMask is a key store and it stores your private keys and it can sign transactions. But it doesn't download the chain data. Instead, it talks to the MetaMask servers and here you have to trust in them. Here's what you learned. A full node downloads all the chain data. Light clients are in development. Geth, if you open it, is a real process that's running in the background and opening a new port, and it's having an IPC file for inter-process communication. The Ethereum TestRPC is simulating the Ethereum protocol and simulating mining, and is perfect for development. MetaMask is a Chrome plugin that bridges to the underlying blockchain. MetaMask is extremely interesting because it makes access to the blockchain very, very easy. Any questions or suggestions, head over to the Q&A. We are here for you and we answer regularly. Have any feedback? We love to hear it. Are you disappointed? Send us a message. We try to resolve. We are aiming for 100% satisfaction and that's important to us.